All right, so we're doing powers of 10 in scientific notation. This directly relates to the explore thing that we did yesterday. So if you kind of keep that in the back of your mind a little bit, I think that'll help. Basically, it's a way that we have to write really huge numbers and really small numbers. So numbers that are really close to zero and numbers that are like ginormous. So I want to start out just by looking at like exponents and powers of 10, kind of give you, basically this is what you learned yesterday in the explore thing. So Roman numeral 1, exponents and powers of 10. So this is part of what you did yesterday, and we'll see how much you remember. If you have a 10 to the third, that's going to be a 1 with how many zeros? 3. Maybe if you want to do the step in between, you could, but 10 to the third is really 10 times 10 times 10, which 1 times 1 times 1 is 1, and then you basically just add up the zeros. So it ends up being 1,000. And that's going to work for any number. You know, if we were to do like a 10 to the 5th, that's going to be a 1 with 5 zeros. So if you think 5 zeros, that's going to be not the 10. So 3, 4, 5, 1. So 5 zeros gets us over to 100,000. It's 6 digits, but it has 5 zeros. So maybe that's what you were thinking when you threw out the 10,000. So here we go. So if we have like a 10 to the 8th, 10. So that's the whole thing is basically, a lot of times they'll call it a power. The 10 is going to be the base. The base is going to be the number that's repeated over and over. So where 10 to the third is 10 times 10 times 10, 10 is the base. The 8 is going to be the exponent. And the answer, you're right, would be 100 million. For this thing here, it's going to be 10 times itself 8 times. So 10 times 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 10, which would be 100 million. So basically it ends up being a 1 with 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. That's what you get if you multiply 10 by itself 8 times. So we okay on powers of 10? All right, moving on to the next thing then. Next thing is my Roman numeral 2. And I have this being converting scientific notation to standard notation. So converting or changing a number in this scientific notation that we're about to talk about. So scientific.
Have you ever thought that it's weird that two odd numbers equal an even number, but an odd number and an even number equal an odd number?
I'm not sure if I've thought about it.
Do you add one? I didn't think about that.
Interesting. Maybe you could try to relate it to odd people and normal people. Okay, moving on though, before we go down that road. So for this here, the key to converting scientific notation to standard notation, we'll have to look at scientific notation soon, but is that you move the decimal. So move the decimal the same number of places as the exponent. So move the decimal the same number of places as the exponent.
Why are you sitting down?
So move the decimal same number of places as the exponent. With this then, for an example, scientific notation, have you guys done anything with scientific notation? Does that sound at all familiar?
No.
I was guessing
Yes.
some yes, some no.
It sounds familiar. I have no idea what it is.
Okay.
Yeah.
Scientific notation will be something like this, 3.27 times 10 to the second. We'll just kind of start with that. And this is one that often you won't see them use because it's not a really huge number. But what they do for scientific notation is they typically always have like one number there, like one number in front of the decimal point, and then a decimal point, and then whatever numbers are left up until the zeros. And then it'll be times 10 to some power. So that's kind of typically what we're looking at for scientific notation. And the key is, if you look at your exponent, so here we have an exponent of 2, we're going to take this decimal point, we're going to move it 2 jumps. So my decimal point goes from between the 3 and the 2 to after the 7. So 3.27 times 10 to the second ends up being 327. And usually you don't put a decimal point at the end of a word or at the end of a number. You don't put the decimal point if it's there, but you could. So let's do another one, and then hopefully we'll see if this starts making some sense. So if I pick instead 3.27 times 10 to the 6th, before we moved it 2 jumps because it was a times 10 squared or times 10 to the second, now we have to take that and move it 6 jumps. So if I start out with my 327, and my decimal point's right there, if I move this thing 6 jumps, do you agree I kind of run out of numbers? That 2 jumps gets me there to the end, but now I have how many more jumps?
4.
4. Now the common mistake is people, well, okay, so I have 4 jumps. So I have 1, 2, and then 3, 4, 5, 6. My decimal point needs to be right here, but what do I put between the 7 and the decimal point? Zeros, exactly. So to kind of hold the place, I have 4 more jumps there, so I have to put in 4 zeros to make it so it's not 327. And then I was always taught putting commas every 3, kind of starting at the decimal point. So you'd end up with an answer something like that. And typically we don't write the decimal point if it's at the end of a number, right? If there's nothing after it, so I can get rid of my decimal point. But 3.27 times 10 to the 6th is really 3,270,000. Yes?
Wow.
The common mistake is this. People see times 10 to the 6th, and they add 6 zeros at the end of the number, and they say, I'm done. But it was 10 to the 6th, we only added how many zeros?
4.
4. Because it jumped 6 places, so 2 places it took to get to the end of the number. So then there's only 4 more places to go, which then gets us up to the 6. So give this one a try. So maybe try this on your own, especially if you're using pencil. 4.815 times 10 to the 5th. So 4.815 times 10 to the 5th. So if you're not looking up, then you're not looking at mine. So see if you can get it done, then kind of compare notes. So did everybody add the 2 zeros? Or am I a little ahead of you? Yep, nice. Because we want to move it 5 jumps, and in moving it 5 jumps, then 3 of the jumps get us to the end of our number. Then we have 2 more jumps to go. So 481,500. How you doing? Are you feeling pretty good?
Yeah.
Now here's a trick that the book will sometimes throw at you, then I'll jump to you, Kate. If I instead had this negative here in front, so negative 4.815, what would I do to my answer? It becomes a negative answer. A little bit later, you're going to kind of see why I'm throwing this in the notes. But if you have a negative number, it's going to be the same sort of thing. You just include that negative over in your answer. So you can add the negative to your notes. You can not add it, up to you. So one last skill to go, and then we're done with the notes. So I have Roman numeral 3. And this is going to be kind of the opposite of what we just did, converting standard notation to scientific notation. So converting standard notation, which really, layman's terms, converting a normal number to scientific notation. So converting standard notation to scientific notation. And this here, if you go back to the examples that we did before. Now, in science class, if you take physics, sometimes you'll have it being a little bit different than what they say here, but normally you're always going to get one number. So you'll have one number, then you'll have a decimal point, and then you put in numbers until all zeros. And this will make a little bit more sense in a second, but one number, point, then you write the numbers until you get to the zeros, and that'll be times 10 to the number of jumps. And that'll make a little bit more sense when we do a few examples. So I have a couple examples written down, then we'll be done. But if I have this 426,800,000, and you could take a number like 52 and write that in scientific notation, but typically you'll see it more for numbers that are really big like this. So my decimal point has to go between what two numbers? The 4 and the 2. Yep. So I just do one number, and then decimal point, and then I write my other numbers until I get to 0. So it'll be 4.268. And we don't have to add the zeros on the end. So scientific notation is most helpful when you have a number like this that ends with a bunch of zeros. Times 10. Now we don't have a decimal point written in this original number. There's no decimal point there. Where is the decimal point in that number? Well, it starts out here at the end, right? Because if a decimal point's at the end of a number, we don't write it. It's just kind of assumed to be there. So we want to take that decimal point from there at the end of a number and put it over here between the 4 and the 2. How many jumps is that going to be? 8. The fastest way to count it, I think, I see a lot of people kind of doing the 1, 2, 3, and you can do that if you want to, but you have a comma every 3, right? So you could just say 3, 6, and then I have 2 more, 7, 8. That's how I do it to save a little bit of time. But you're right, it's going to be 8 jumps. So 4.268 times 10 to the 8th. Good? I don't know if you want to write a couple more or if you want to just kind of watch and I'll quick do a couple. Decimal point goes between the what and the what? 5 and the 1. So 5.1. Do we write the zeros? Nope. So 5.1 times 10 to the 6. Yep, so if you do your commas, you have 3 jumps to that first comma. Or I could try to do that. So it starts out here for my decimal point, and then you have 1, 2, 3, 4, 5, 6. Or you could just say I started here, then I have 3 and 6, and we're done. So 5.1 times 10 to the 6th. If I were to do 28,100. So it goes between the 2 and the 8, so 2.81 times 10 to the 4, yep. You don't count just the zeros, you need to count the number of places you moved it. So it started out here, and we had 1, 2, 3, 4 spots, so 4 jumps. 10 to the 4th. Feel like you know enough to be dangerous? Just a quick comment for why it works. If you have 3.47 times 10 to the 3rd, that's the same as 3.47 times 1,000. Which then, if you would multiply that, the 3 ends up where the 1 is, and you'd have the 4, 7, and 0. So really, scientific notation is just saying, all right, I have this number with a decimal times 1,000 or 100 or 1,000,000 or something like that, which essentially then just moves the decimal point to the end.